welcome to our second experiment with the eForTraining.com simulation program. Today we're going to just look at pump types and their energy usage, so the power in. So we're trying to design the most efficient system, and the intention is that you use the simulation program to put your own components in sizes and see which is the most efficient system for you before you actually build it. So let's look at this circuit here. We can put the test gauge on. It tells us our pump is got a pressure of just over 2 bar, flow of 10 litres a minute. It's fixed displacement, so the flow has to go somewhere. Now it's going around straight to tank, an open centre valve. So we're using very little energy, which is good. If we operate the valve, then it runs to the end of the cylinder again using very little energy because there's not a lot of no load on the system, but actually it's using full energy there once it's against the end stop. Set in the center position again, it's nice and efficient, but if we switch to a closed center valve, because the open centers quite often aren't, you can't use them because of the rest of the circuit. Now the relief valve is operating, so the relief valve is open. We're putting all of our flow through the relief valve on maximum pressure, so we're running at over 200 bar, and you can see we're using full power. So not the ideal system. If it's sitting on valves closed most of the time, like a lot of them do, then you're just wasting all your energy, which is not good at all. So what we can do, select the free pump energy usage comparison, select our new circuit, and we've got a variable displacement pump here now. And we can see with a variable displacement pump, even though we're using the closed center valve, we've got 180 bar, so we're working full pressure on it. The relief valve is shut, it's not doing anything, so that's good. It's not wasting energy, but the setting now is set higher than the pump. You could argue we don't need it, but it's a nice safety device. We pretty much always put one in for additional level of safety, which again is another good thing. But you can see as it's sat here, no flow, using very little energy. When we operate it, we don't use. I'll double click on there. If you double click on the body, it stops the cylinder moving. The circuit still thinks it's moving, but it just gives us more time to investigate. And as we're moving now, we are using more energy, but that's because we've got a flow control valve in. And if we look at this, we can see this is set to 4 litres a minute at 300 bar, which we've only got 180 bar on our pump. So we're getting lots more pressure, and that's because if we follow the circuit through and look at the cylinder, we've got different areas. So we've got a pressure here of 170, we've got a pressure on the annulus side of over 300. So we've got flow here of 7 litres a minute from our pump, and that's not full flow. The pump is capable of more, but because it's pressure compensated, it's regulating, and it's only giving us the flow we require. And you can see we've got a smaller input power. We're using less power than we would do if we were driving with all the flow. But we are generating this intensified pressure on the annulus side, so you do need to be aware of that and be careful, because you can't use a cylinder that's rated lower than this full pressure that it will see. But this is a nice little design. We'll just release that, and again, when we get to the end stop, the pump backs off, energy goes down because it's only supplying the leakage flow through the valve. So let's take this back. No flow control this way, so we'll work at full flow. Now what happens if we change and put in the fixed displacement pump? We're on closed center, so the flow coming here has to go somewhere, but we've got our relief valve set higher than our pump, if you remember. So that's going to cause our pump to explode, which is not a good thing. So we'll have to reset the relief valve. Now the relief valve's open, and we're wasting all our energy again through this system. And the important thing now is if we operate this, and we'll just stop it again, we can see that we've just got this, it's a bit lower in pressures. We've got our 4 litres a minute here, but notice the pump has to produce its full flow. So we're set with 20 litres a minute, and it has to produce that flow. So that flow will go across the relief valve, which is why pressure's gone up to our new relief valve setting. So most of the flow is going across the relief valve, and we've got some flow going across here. But again, look at the energy usage. It's an inefficient way to do things because we're using a lot more energy than we did with a variable displacement system. It's a cost issue. It might be cheaper to do it this way, but you need to look at that, look at your own systems and decide what to do. But again, you have to be aware of these issues, the intensification and also the energy usage under different center conditions and different flow control conditions. I hope that's helped.